Welcome back. In this video, I'm covering data sharing. Often this is a concern after your project has reached completion, but even during the course of your project, if you're collaborating with others, it may be necessary to share your data, and there are certain considerations you'll want to account for. As you plan to share your data, you should be aware of some of the different classifications of data sharing. Open data is data that anyone can access, use, and share under the terms of the license. It is published without restriction. Shared data can be made widely accessible just as with open data, but it might also have conditions like limiting reuse to non-commercial purposes or to allow reuse with attribution given to the author. Closed data is not shared at all. But some of the metadata might be shared, especially if you're interested in enabling other researchers to understand how you created the data, or would like them to be able to replicate your methodology. You might share the metadata about how the data was collected and processed in such cases. Some journals and funding agencies have data sharing policies. Journals in particular may provide a list of recommended repositories. For example, Nature Scientific Data is Springer Nature's data journal, and they provide a list of recommended repositories depending on the relevant discipline. Fair data practices are a list of best practices for sharing data. Under the ideal situation, your data will be findable, accessible, interoperable, and reusable to both humans and machines. As machine learning becomes more and more prevalent, I imagine fair data is going to increase the usage of those data sets that adhere to the FAIR principles. Findable means using persistent identifiers like DOIs, providing very rich metadata that allows others to reuse the data, using indexed data repositories that are easy to find, and utilizing persistent identifiers in the metadata so that links to the data remain in place regardless of migrations. Accessible means using standard communication protocols so that the data doesn't require any unusual proprietary software to access. Open free protocols take that a level further, and as I mentioned in the previous video, non-proprietary freely licensed software is best practice for data storage. Fair data practices do not preclude closed data from being fair. You may still require authentication, but in such cases the metadata should still be available to everyone. Interoperable means that you're using common vocabularies. The vocabularies themselves should be standardized and follow the FAIR principles, being findable, accessible, interoperable, and reusable themselves. FAIR data should have linked metadata. Without getting too detailed, linked metadata relies on what are known as semantic triples that define how one item relates to another. This is similar to hyperlinks in Wikipedia that allow you to go down the Wikipedia rabbit hole. Linked metadata should allow folks to access related publications and datasets. Reusable means that metadata contains the appropriate attributes and licensing that makes reuse straightforward. Additionally, the provenance of who created or how it arrived at a particular repository should be clear to researchers who are looking at it. Lastly, the data should follow community standards with regards to storage, metadata, sharing, and all the other principles. Aberrant standards can make reuse a challenge. As you're thinking about where you want to store your data, I recommend considering different repositories depending on the data that you're creating. For data that might be of broad or general interest, or if you imagine researchers across disciplinary bounds are going to find it useful, multidisciplinary repositories can be a fantastic place to store that type of information. Some examples of multidisciplinary repositories are Figshare, Zenodo, Dryad, Mendeley Data, and DataHub. These repositories may have different requirements. Some of them charge. I know Figshare charges for files over 20 gigabytes. For relatively small data sets, the free versions of these platforms can be perfectly appropriate and can help get your research out beyond your discipline. As I said, they may also have these premium allowances for larger data sets, but that often comes at a cost. There are also disciplinary repositories. There are far too many disciplinary repositories to list here, but directories like Re3Data can direct you to specific repositories within your area of study. This is beneficial both when you're looking for a storage solution and when you're searching for data that might be available to you. As you're searching, you can filter repositories by various facets like country, but also you can filter them by certifications like the CoreTrust seal. The CoreTrust seal relies on 16 factors to assess that a repository adheres to the highest standard of quality. Not all repositories qualify for the CoreTrust seal, nor do all repositories apply for the CoreTrust seal certification, but if you find a repository with this seal, you can be pretty certain that they're adhering to the best practices for data storage and preservation. Finally, you might consider an institutional repository, and local storage as a means to share your data. Institutional repositories collect research output from a single institution. Typically, they limit the file size that you're allowed to upload to the repository, and they're intended for sharing broadly, generally not in a way that allows for internal use only. If you don't intend to share your data broadly, an institutional repository is not an appropriate long-term storage solution. Still, it ties your research back to the institution and allows researchers a place to find and access your data. Generally, this is not appropriate for larger data sets, but that doesn't mean that your institution is without appropriate solutions for those large data sets. You might ask your institution's IT department if they have any available solutions. Typically, institutional solutions are less expensive than external storage solutions. The campus generally does their best to keep costs down. Additionally, many research offices take some portion of a grant for overhead, which goes to supporting things like this. If part of your grant is going to support infrastructure that benefits your research, you may as well utilize the services that are at your disposal. Additionally, many of these institutional solutions have options for sharing more broadly, but also for keeping your data private and allowing you to work on the living data set that is being produced through the course of your research. So far, we have covered why you should care about data management, the considerations that you should take into account when you're managing your data, and some strategies and locations for sharing your data. Up next, I have an activity where I'll have you search for a data repository and find data within your discipline using re3data.